All right, y'all, today's notes are going to be on solving radical equations. So make sure you get the notes title in your notebooks, 3.3 notes, solving radical equations. And we are going to start right here with this orange text. Be prepared to explain how the problems below are similar and also how they differ. So let's look at these two problems. We have A and B. And I want you to tell me, how are these problems similar? And then how are they different? All right, so hopefully we recognize the biggest difference in these problems is we have a square root in problem B, but other than that, they're like pretty much identical. We have 3, we have plus, we have 2, multiplying right here onto the square root of x, and then we have 7. Okay, so these are very, very similar problems. What is the point of recognizing the similarities? Well, I don't want us to be freaked out by this square root. We're not going to freak out when we see a square root. We're going to think of it as this type of problem, this easier looking type of problem. We are going to realize, oh, normally in a problem like this, we're trying to isolate x, and we're going to do the same thing, and we're actually going to take very similar steps to do so. So for example, what would the first step be to isolate this x in this problem? Well, when you're isolating x, you should always start furthest away from x. So what number is furthest away from x? This 3. So we need to remove that. The 3 is adding. So we're going to do inverse operations. Subtract 3, subtract 3. We would do the exact same thing to solve problem B. We would subtract 3, subtract 3. The next step we would do is divide by 2. That's the same thing here. We would divide by 2 after we minus 3 on both sides. Okay, so all I wanted to point out is that this type of problem, although it has a square root, it is not a scary problem, and you guys are going to crush it. All right, so let's go ahead and start notes for today. So get down this example and be prepared to write down 4 steps for this type of problem. All right, the example is solve for x. We are trying to isolate. Solve means isolate. Solve means your answer should look like x equals. That's what your answer should look like if you're solving. X equals something. So solve for x, and then check for extraneous solutions. We will talk about what extraneous solutions are in a second. Okay, and then we have this problem. So make sure you write down the problem. 2 times the square root of 2x plus 8 minus 3 equals 1. And again, this is called a radical problem because it has a square root, so that's why we call it radical. Okay, let's go ahead and start with our first step. First step, isolate, which means get alone, which isolate means get alone. Isolate the square root. So we're going to start by isolating the square root. Get this square root thing alone. All right, so what does that mean? We need to get the square root and anything that's under the square root alone. So what do we want by itself? We want this whole thing by itself. The square root and anything that's under it. So we need to move 2 things. We need to move this 3 and this 2. Which one should we move first? Which one should we use inverse operations on first? We need to use inverse operations on the one that is furthest away from the x. The 2 is multiplying on the x. The 3 is furthest away. It's subtracting. So we're actually going to use inverse operations on the 3. So we're going to add 3 on both sides. Plus 3, and let's write what we have left. We have 2 times the square root of 2x plus 8. These 3's go away, equals 1 plus 3 is 4. All right, we still have not gotten this square root alone. We want to isolate this. We still have that pesky 2 on there. So what are we going to do? I'm going to actually show my inverse operations in purple to distinguish the difference. There we go. Okay, so what do we need to do to isolate the square root? This 2 is multiplying. So we're going to do the opposite. We are going to divide both sides by 2. Divide by 2, divide by 2. Those 2's are going to cancel out. And now we have 2x plus 8 under the square root equals 4 divided by 2 is 2. Sweet. We are done with step 1. We have isolated the square root. We've gotten that square root piece alone. Next step. Let's go on to the next step. And the next step is square both sides. All right, and let me explain why. Square both sides. All right, and remember that square is not the same as square root. This is square root. This means square root. Square means like a little exponent of 2. So we're going to square both sides. Why are we doing that? Because we need to use inverse operations to isolate x. The opposite of square root is square. So the inverse operation of square root is square. When we square, this is a square, right? This is a square root. When we square a square root, that makes the square root cancel out. So we're going to say, okay, I'm going to square, I'll show you what I do when I do my steps. I'm going to square the square root so the square root cancels out. I kind of like cross it out right there. But whatever you do to one side, you have to do to the other side. So we also need to square this side. So now let's write down what we have left. The square root went away. It canceled out. So now we have 2x plus 8, because the square root went away, equals 2 squared is 4. All right, when you square a square root, that square root disappears. That square root symbol disappears. Sweet. Let's move on. So let's move to step 3. We already did square both sides. Now let's move to step 3. Step 3 is solve for x. We need to isolate x. Solve or isolate x. Y'all can definitely find x. Get x alone for me. Tell me what x equals. All right. We are going to subtract 8 on both sides. So we have minus 8, minus 8. You get 2x equals negative 4. Divide by 2. Divide by 2. And we get x equals negative 2. Sweet. All right. Now, we are not, normally we would box this, right? We would box this and we'd be like, okay, yay, that's our answer. But we are not allowed to box this yet because we need to do the final step. We need to check for extraneous solutions. Extraneous solutions. And you do need to know what this word means. So, extraneous solutions are actually solutions that don't work. How do we do this? How do we check to see if they work? You're going to plug back in. So, let me show, or plug, let's write, we're going to plug x back in and see if it works. And I'm going to show you what I mean. So right now, we have x equals 2. We don't know if that's actually the real solution. We first need to plug it back into what we started with. So where are we going to look? We're going to look here. So let me write down this equation that we started with so that we can kind of like look at it as we check for extraneous. Here's where we started. We started with this, 2 square root of 2x plus 8 minus 3 equals 1, right? Okay, and actually I need to make sure that square root doesn't look like it's going on the negative 3. Okay, so this is what we started with. When I say plug in for x, I mean plug in for x. So we're going to only plug in what we got for x and we're going to check if it works. So we're going to say 2, I'm going to plug in negative 2 for x. So let me do that really quick. And I'm going to do it in a different color to let you know like what I'm doing. And now you need to leave this side alone. Kids are usually tempted to like add 3. Don't do that stuff. Don't do extra. Literally all we have to do is simplify. We're going to simplify this side and we're going to check. Do we get 1? Because we need to get 1 for this to be a real solution, for negative 2 to be a real solution. So let's go ahead and simplify. So we get 2 times negative 2 right here. That would be negative 4. So we have 2 square root of negative 4 plus 8 minus 3 equals 1. All right, let's simplify more. That turns into 2 square root of 4 because negative 4 plus 8 is positive 4. Minus 3 equals 1. Leave 1 by itself. We're just simplifying the left-hand side. Square root of 4 is 2. So we have 2 times 2 minus 3 equals 1. And then 2 times 2 is 4. We get 4 minus 3 equals 1. Is 4 minus 3 1? Yes. 1 equals 1. All right. This is awesome news. We got the right thing. This is true. This is true. 1 does equal 1. So what can we do? We can go back up to our solution, x equals negative 2, box it, and say this is our real solution. This is the solution. Now, an extraneous solution is going to be something that if we plug it in, we actually don't get a true statement after simplifying. And we'll see that next class. But for now, we're going to be working with real solutions. You still need to do this extra step of checking with extraneous. You need to do this last step, check for extraneous, anytime you have a radical. Why do we need to do that step? Because, y'all, we have domain restrictions. Anytime you have a domain restriction, remember how we talked about there are x values that will break this function? Anytime you have an x value that will break a function, you have to plug your solution back in, whatever you get when you solve, and you have to see if it works. Because you might actually get an x value that is restricted or not allowed, and you have to double check. Okay, now let's do some practice.